In this class, we're going to consider perpendicular bisectors. So this is a straight line topic, and it really all hinges upon knowing the definition of a perpendicular bisector. So notice there's two parts to that definition: perpendicular, which is right angled, and bisector, which means, cutting something in the middle, so the median, basically. So just a quick reminder of the kind of theory. If you've seen this before, or if you've not seen this before, then this will be new to you. But basically, what we're interested in here is, if you've got a straight line, let's maybe call this line, well, we'll just call it AB to match the example I'm going to do in a second. So you've got a line with endpoints AB, and we want to find the perpendicular bisector to that line. Well, the bisector means that it cuts in the middle, so we know that this midpoint has to lie on the line. The perpendicular part means that it's right angled to that line. So we're talking about a line that comes down something like this, where each of these is a right angle. So the fact that we know it's perpendicular is going to help us to solve the question, and the fact that we know it's a bisector is going to help us. In particular, it's going to help us because we're trying to make the equation of a line. To find the equation of a line, which eventually will be in the format y equals mx plus c, we need two things. We need a point on the line, let's call it point AB, and we need the gradient, okay? So the fact that we can find the midpoint from the endpoints is going to allow us to get the point on the line. The fact that the lines are at a right angle to each other is going to help us to get the gradient. So one thing that tends to come up in these questions is the midpoint formula, because we've got this midpoint. The midpoint formula basically allows you to find where, if you've got two endpoints, where the middle point is. It's a little bit over formalized, but it basically looks like this. It says if you've got 2 points, x1, y1, and x2, y2, let me make that into an x, x2, y2, then you can find the midpoint of those by basically adding your x's together, so x1 plus x2, and then dividing by 2, and then adding the y's together, y1 plus y2, and dividing by 2. And that's absolutely fine. That's a great way to do it. So I would say add these guys together, divide by 2, add these together, divide by 2. Perfect. You probably don't need to go as far as writing it out every time, because you want to kind of use this at speed. Another way you can do it is if you look at those two coordinates, then the difference between them is 6, half that, and then add that to that one, or subtract it from that one, and that will land in the midpoint. So difference is 6, half of that is 3, add that on to 1 and you would get 4, add that on, take it away from 7 and you would get 4 as well. Or add those together, like this part of the midpoint formula, and divide by 2. 1 plus 7 is 8, divided by 2 is 4. So it doesn't matter which method you use, you'll get the same answer in the end. Okay, so a typical scenario with this topic would be where you're given 2 points, like we've got in the example here, and you're going to find the line that's a perpendicular bisector of the line joining those 2 points. You don't necessarily need a diagram, but I'm going to draw a diagram for this one just to illustrate what's going on. The good thing about having a diagram, it allows you to maybe make a guesstimate as to what the answer will come out to be. If you can check your algebra work against the geometry, then that's going to validate whether the answer could be correct or whether, it's gone horribly wrong. So let me straighten up my XY axis and then we'll make a start. So just marking on these 2 points, so minus 1, 1, that's minus 1, 1 roughly there, that's point A. 3, 7, try and draw these reasonably accurately. The more accurate you can make this diagram, the more chance that you can use it successfully to get orientated about your answer. So these are basically our 2 points, point A and point B. So we're going to draw a line through them. It's not the equation of this line that we're interested in. It's very tempting in these questions to just go ahead and make the equation of that line. It's a perpendicular bisector. So we want to chop the line in the middle. So that's going to be somewhere around there. And again, try and be reasonably accurate in drawing this on. And then it's the line that's perpendicular to that line. So it's going to be something like that. Now, why is that useful? Well, it's useful because it tells us that the line we're interested in has got a negative gradient. Okay, so it's sloping down the way to the right. And it also tells us that the y-intercept, this point here, is positive, and it lies between the points A and B. So we can use all that later on to check that the answer that we get kind of makes sense. So what we're going to do, we're going to start by making the gradient of the line AB, and we're then going to use the negative reciprocal of that to get the perpendicular gradient. Remember that if two lines are perpendicular, and if they've got gradients m1 and m2, then m1 times m2 equals minus 1. But in reality, if you know, for example, that one of the gradients is 3, then the other gradient, the perpendicular gradient, must be minus 1 over 3. And we call those the negative reciprocal of each other. So let's start by making the gradient, so the m value of the line AB. Just going to use the y2 minus y1 over x2 minus x1 formula, or you might know that as the vertical over the horizontal. Doesn't matter which way you think of it. Just watch out for negatives and double negatives when you're using that formula. So 7 minus 1 divided by 3 minus minus 1, so that's going to be 6 over 4, and we can simplify that down to 3 over 2. If you're using the formula here to flip the gradient, keep it as a fraction. You could make this in normal questions and other questions into 1.5, but to take the negative reciprocal of 1.5 is going to be a lot more difficult than just flipping this fraction. So we know if this line AB's got a gradient of 3 over 2, which looks pretty good on the geometry, then the other line, I'm just going to call that M perp, because it's perpendicular to it, this line here, our line, must have a gradient of minus 2 over 3. That's just using this rule here. Okay, so we know our gradient now. We don't have any points on our line, so we're not ready to make the equation. Now we need to figure out the midpoint of these two. So we'll just maybe call that the midpoint. And the midpoint is just going to be the middle of these points. So adding these together, minus 1 plus 3 is 2. Divide that by 2 is 1. So the x-coordinate is 1. And we checked this one out already and said that the midpoint had a y-coordinate of 4. So that's telling us that this point should be at 1, 4. So looking again at the diagram, 1 along, 4 up, looks pretty good. So we've got all the bits that we need. We've got the gradient, we've got a point on the line. I'm going to go ahead and use the y minus b equals mx minus a version of the straight line formula. You can, if you wish, go straight to this version and manipulate the algebra using that version. I prefer this method. Either way is fine. So just plugging in the a and the b values. The b value is 4. The gradient is minus 2/3 minus the a value, which is 1. You can just multiply out the bracket at this point. I'm going to times through by 3 to get rid of the fraction. So multiplying everything by 3, 3y minus 12 equals minus 2. Just leave the bracket maybe for now. Multiplying out the bracket to give minus 2x plus 2, so a double negative there, and then just taking everything apart from the y term to this side, so I'm just going to move my working up here. So we would end up with 3y equals minus 2x, then you've got plus 2, and you're moving the minus 12 over, which becomes a plus 12, so it's plus 14, and then just dividing through by 3 to get the final correct format. So slightly unfortunate that this one has got fractions, but it's fairly common for these to have fractions in them. Doesn't mean anything's gone wrong. So just checking the final answer that we've got here. So the gradient minus 2 over 3, that's fine, we'd already checked that one, it fits in with the geometry. Plus 14 over 3 is the y-intercept. Well, let's just think about that. 14 over 3 is approximately 5, it's a little bit below 5. This point here, B, has got a y-coordinate of 7. So that height there, if you like, is 7. So if that there is 7, a little below 7 is 5. So 14 over 3, which is approximately 5, seems to be 14 over 3 in the right place. So just having a diagram, even with these awkward fractions, allows you to validate that the answer is correct. So that's how you'd go about finding a perpendicular bisector. I've exaggerated that example a little. You don't really need the diagram. If you trust the algebra, then that's fine. You don't really need this if you know the formula. You could just scoot through this part of the work and quite quickly. They're fairly short questions, these. They're not particularly difficult. They're just an application of what you probably already know about straight lines. The key is really just knowing the definition. Perpendicular bisector, those two parts, perpendicular, bisector, that's going to allow you to get your point on the line and the gradient, and then just put that together to get the equation of the line.